October 25th, 2025. Saturday. Evening twilight was falling over Tokyo when the first post appeared in the Japanese segment of social media. A blurry image, supposedly taken with an amateur telescope, captioned in English, "Real footage 3I Atlas. This is not a comet. Not a comet, a ship." Within an hour, the post had racked up 8,000 reposts. By midnight Moscow time, screenshots had spread through Russian-language Telegram channels dedicated to ufology and astronomy. By Sunday morning, it was trending. Millions of people stared at the same pixels, trying to make out the contours of something impossible. But to understand where this story came from, we need to go back several months, to the very beginning, to July 1st, 2025, when humanity didn't yet know the name 3I Atlas. Write in the comments where you're watching this video from and what time it is for you right now. It's important for me to know who's listening to this story. July 1st, a high-altitude observatory in the Chilean Andes. The Atlas Telescope System, Asteroid Terrestrial Impact, Last Alert System, was scanning the night sky in automatic mode. 4 telescopes located at different points on the planet photographed millions of stars every night, calculating moving objects, asteroids, comets, potential threats. The algorithm detected an anomaly in the constellation Ursa Major, an object moving at 62 kilometers per second, too fast for solar system objects. Hyperbolic trajectory. The object had come from somewhere beyond, from interstellar space. The third interstellar object in observation history. The first was Oumuamua in 2017. The second was Comet Borisov in 2019. Now the third, it was designated 3I Atlas. The first spectral data surprised astronomers. The object displayed a bright green coma, a cloud of gas around the nucleus. The green color indicated elevated levels of diatomic carbon, a molecule that breaks down under solar radiation. This happens with comets, but the intensity of the glow seemed unusual. The shape also raised questions. Initial low-resolution images showed an elongated, almost cigar-shaped silhouette, about 800 meters long and 200 wide, according to preliminary estimates. The albedo, reflectivity, turned out to be low, just 4%. The object absorbed light as if covered with a layer of dark organics. The international astronomical community immediately pointed all available instruments at the new target. The Hubble Space Telescope, the James Webb Space Telescope, the Mars Express probe passing by on its orbit. All of them began an observation campaign. By mid-July, enough data had accumulated for the first scientific publications. Papers came out as preprints, preliminary versions that hadn't undergone full peer review. Astronomers rushed to share their results. Comet 3I Atlas was indeed interstellar. Its composition differed from solar system objects. Elevated ammonia content, methane, traces of complex organic molecules. Age. Millions of years spent in the cold, interstellar void. Where did it come from? Backward trajectory calculations pointed to a region of space in the direction of the constellation Hercules, but the exact star of origin couldn't be determined. Perhaps the object had traveled hundreds of thousands of years before accidentally wandering into our system. The public followed the news with interest, but without panic. Just a comet. Beautiful, unusual, but a comet. August brought the first high-quality images. James Webb pointed its infrared detectors at 3I Atlas and captured a stunning shot. The comet's nucleus wrapped in an expanding coma, green glow forming concentric waves like ripples on water. The tail stretched 700,000 kilometers, curved by solar wind pressure. The nucleus shape became clearer, an elongated ellipsoid, the surface uneven, covered with craters and fissures. No signs of artificiality. Scientists breathed a sigh of relief after Oumuamua, whose behavior spawned numerous speculations. Some seriously suggested an alien probe. Every new interstellar object was examined with special attention. But 3I Atlas behaved like an ordinary comet. It evaporated, formed a tail, no anomalous accelerations or trajectory changes. Data was published openly in publicly accessible archives. Anyone could download images, study spectra, check calculations. September, the comet was approaching perihelion, the closest point to the sun in its orbit. Brightness increased. In the northern hemisphere, it could be observed with the naked eye as a faint greenish spot in the pre-dawn sky. Amateur astronomers around the world aimed their telescopes, posted photos in specialized forums. Image quality varied, from professional shots taken with equipment worth tens of thousands of dollars to blurry images from cheap amateur refractors. It was these amateur photos, grainy, with artifacts, with overexposed areas, that later became the basis for conspiracy theories. In some photographs, the bright coma created lens flares. Star trails during long exposures overlapped. Sensor noise formed random patterns. The human brain is wired to search for familiar images in chaos. Pareidolia. We see faces in clouds, figures in stains on walls, ships in blurry pixels. October. The comet passed perihelion on October 12th, at a distance of 120 million kilometers from the Sun, slightly closer than Venus's orbit. Maximum brightness. The tail stretched 1 million kilometers. Photos flooded social media. Millions of people went outside to look at the rare phenomenon, an interstellar comet, a visitor from another star system, sweeping past our planet. Scientists continued observations, published more and more data. Nucleus mass refined, about 2 trillion tons. Low density, the object was porous, like a ball of dirty snow. Slow rotation, period about 48 hours. Everything fit models of ordinary comet behavior. No surprises, no mysteries. But it was at this moment, when the scientific community had practically closed the topic as a routine observation, that a rumor began brewing on social media. October 23rd, Thursday, a post appeared in one of the Japanese social media groups from an anonymous user. Text in broken English. Friend working at university showed me real image. They hide truth. 3I Atlas not comet. No photos, no proof, just a statement. The post got a few likes and was forgotten. But a day later, on October 24th, another user published an image. Blurry, low resolution, clearly taken with a phone from a monitor screen. The shot showed an elongated object surrounded by glow and a caption, "Leaked from observatory. They don't want you to see this. Leak from an observatory. They don't want you to see this." Classic conspiracy formula. Secret information. Conspiracy of silence. Truth being hidden. October 25th, Saturday. In the morning, the image was reposted by a popular blogger specializing in ufology. He added his own comment. Source is credible. This could be a breakthrough. Shape doesn't match a natural object. Possibly we're dealing with technology. The blogger had 2 million subscribers. The post exploded. By noon, 100,000 reposts. By evening, 500,000. Screenshots spread to other platforms. Twitter, Reddit, Telegram. Russian language channels picked up the topic with enthusiasm. Leaked real footage shows large ship instead of Comet 3I Atlas. Headlines became more and more sensational. Scientists hiding truth about alien probe. interstellar ship approaching Earth. This is not a comet. This is a message. By the night of October 25th, several different images were already circulating online, supposedly representing real footage of 3I Atlas. The first, that same blurry photo from a monitor screen. The second, an obvious fake, where the comet's nucleus was replaced with a CGI model of a spaceship from a science fiction movie. The third, an amateur shot with heavy overexposure, where the bright coma created an artifact in the shape of a cross, and someone captioned, "Symmetry too perfect for a natural object." The fourth, a completely fictional image created by a neural network with a hyper-realistic metallic object against a background of stars. Each image was accompanied by claims of a leak and conspiracy. Millions of people watched, commented, argued. Some believed, others doubted. Still others demanded proof. Sunday, October 26th, 2025. Morning. The first rays of sunlight slide across the screens of millions of smartphones, where yesterday's sensation continues to circulate. Comments multiply by the minute. This will change everything. Governments are silent. Finally, proof. But parallel to this wave of excitement and anxiety, in another segment of the internet, work begins. Amateur astronomers, professional researchers, science enthusiasts, they all open those same images and start analyzing. Not emotionally, methodically, pixel by pixel. Because before believing an extraordinary claim, you need to rule out all mundane explanations. And in space photography, there are dozens of mundane explanations. Let's start with the most basic concept. What are we seeing when we look at a photograph of a comet? Not the comet itself. Never. We're seeing light reflected or emitted by the object, traveled through space, collected by telescope lenses or mirrors, converted by the camera sensor into electrical signals, processed by a chip, encoded into a digital file, transmitted over communication channels, decoded by software on your device, displayed on a screen. Each of these stages introduces distortions, some minor, others dramatic. Professional astronomers know these distortions by heart, account for them, correct them. Amateurs often don't know, and ordinary people scrolling through an image on social media have no idea the problem even exists. The first and most common artifact, overexposure. When an object is too bright for the current camera settings, the sensor becomes oversaturated. Pixels reach their maximum value, stop distinguishing details. Brightness bleeds into neighboring areas, creating a halo, glow, blurred radiance. With Comet 3I Atlas, the coma, the cloud of gas around the nucleus, glows intensely due to diatomic carbon fluorescence. Green glow. If an amateur astronomer uses a long exposure to capture the faint tail, the central part of the coma inevitably overexposes. In the final image, instead of a sharp nucleus, a blurred spot, sometimes round, sometimes elongated, depending on the optics settings. The European Space Agency, back in 2014, published images of Comet Churyumov-Gerasimenko, taken by the Rosetta probe. The coma images clearly show circular bright structures to the right of the nucleus, artifacts of the optical system caused by overexposure of the bright nucleus. The second artifact, star trails. Earth rotates. If the camera is fixed on a tripod and takes a long exposure, stars turn into lines, arcs, traces of the celestial sphere's movement. Professional telescopes use mounts with automatic guiding that compensate for the planet's rotation. But the guiding system can fail, especially on amateur equipment. The result, stars smear, forming streaks. If a bright comet is present in the same image, Visual confusion arises. Star trails overlay on the coma, creating the illusion of structure, geometry, something ordered. The human brain, seeing lines, automatically tries to find a pattern, a rectangle, a cross, a silhouette, a ship. The third artifact, sensor noise. Every camera sensor is a grid of millions of tiny light detectors, pixels. They're not perfect. Even in complete darkness, when not a single photon hits the camera, pixels generate random signals. Thermal noise caused by thermal motion of electrons in the semiconductor. The higher the sensor temperature, the stronger the noise. Professional astronomical cameras are cooled to -60 to -100 degrees Celsius to minimize the effect. Amateur cameras typically don't have cooling. With long exposures, tens of seconds, minutes, noise accumulates. Random bright spots, patches, grain appear in the final image. If the object's illumination is weak, the signal-to-noise ratio drops. The image becomes grainy. The eye can mistake a cluster of noise pixels for detail on the object. The fourth artifact, compression artifacts. When an image is saved in JPEG format, the algorithm compresses data, discarding information it considers redundant. This creates characteristic square blocks, 8 by 8 pixels in size, especially noticeable in areas with low contrast or smooth gradients. Astronomical images often contain large areas of black sky with sparse bright points, ideal conditions for compression artifacts to appear. If such an image is then scaled, processed with sharpening filters, artifacts intensify, become distinct. False lines, geometric shapes, stepped edges emerge. The fifth artifact, the human brain itself. Pareidolia, an evolutionary pattern recognition mechanism that once helped our ancestors notice faces in bushes or predator silhouettes in shadows. The brain is tuned to search for familiar shapes in any visual noise. Faces, figures, objects. This happens automatically, unconsciously. You look at a cloud and see a dragon. Look at stains on a wall and see a person's profile. Look at a blurry photo of a comet and see a ship. Not because there's a ship there, but because your brain fills in the gaps, interprets ambiguity in favor of a familiar image. NASA even published special articles about this phenomenon, showing examples of space images where people saw hands, faces, figures, and all of them turned out to be gas clouds, nebulae, star clusters, whose random shapes simply resembled something familiar. The history of space exploration is full of examples of such false interpretations. The most famous, the face on Mars, July 25, 1976. The Viking 1 orbiter was photographing the surface of Mars in the Cydonia region, selecting possible landing sites for Viking 2. One photograph showed a rock formation about 1.5 kilometers wide that, under certain lighting, resembled a human face. Eyes, nose, mouth. NASA published the image with a caption calling it a shadowy likeness of a human face. The agency hoped to draw public attention to the Mars program, and attention was drawn. Journalist Richard Hoagland and his followers declared that the face was a monument built by an ancient Martian civilization. A campaign began, demanding additional research, accusing NASA of hiding the truth. 22 years passed. April 1998. The Mars Global Surveyor orbiter flew over the same region and took new images with much higher resolution. There was no face. An ordinary mesa, a table mountain formed by erosion with an uneven surface covered in craters. The original face arose from a combination of factors: low image resolution, lighting angle around 20 degrees, shadows filling depressions and creating the illusion of facial features, and transmission errors, bit errors, that appeared as black dots that became eyes and nostrils. When the sun was at a different angle and a camera with better resolution photographed the object, the illusion disappeared. But for conspiracy theorists, this became proof of a cover-up. NASA is hiding the truth. New photos are faked. They deliberately blurred the face. Conspiracy logic is impenetrable. Any refutation is interpreted as part of the conspiracy. A similar story happened with Oumuamua itself. October 2017. The Pan-STARRS telescope in Hawaii discovered the first confirmed interstellar object. Hyperbolic trajectory. Speed too high for a solar system object. Unusual shape. Elongated, possibly 10 times longer than its width. Low albedo and strange behavior. A slight non-gravitational acceleration when moving away from the sun. Most scientists explained this by outgassing, evaporation of volatile substances from the surface, creating reactive thrust like an ordinary comet. But Harvard University professor Avi Loeb proposed an alternative hypothesis. Oumuamua is an alien probe, possibly a light sail using solar radiation pressure for propulsion. The hypothesis triggered a storm of criticism from the scientific community, but widespread media resonance. Every new article by Loeb was spread as confirmation of the alien version, although the author himself cautiously called it just one of the possibilities. By 2025, the scientific consensus remained unchanged. Oumuamua is a natural object, most likely a fragment of nitrogen ice broken off from an exoplanet similar to Pluto hundreds of millions of years ago. But Loeb's name became associated with the search for extraterrestrial intelligence. And when Comet 3I Atlas was discovered in July 2025, the third interstellar object, Loeb and his colleagues published a preprint article called A Pedagogical Exercise, a Thought Experiment. In the article, they didn't claim that 3I Atlas was alien technology. They merely listed anomalous characteristics and offered alternative theories to explain them. But media headlines were predictable. Scientists don't rule out alien origin of 3I Atlas. Interstellar ship disguised as a comet? The article became fuel for conspiracy theorists. It was this article, published in late July, that laid the groundwork for the October leak. Because when a respected scientist from a prestigious university even hypothetically allows for the possibility of alien technology, it creates space for speculation. If a Harvard professor thinks it's possible, then there must be something to it. Forgetting that science doesn't work that way, a scientist can propose any hypothesis, even an extraordinary one, but it must be backed by evidence. And there was no evidence of alien origin for 3I Atlas. All observations, all spectra, all trajectory measurements pointed to an ordinary comet. Amazing because interstellar, but a comet. Morning of October 26th. In scientific forums, detailed analyses of the leaked images begin to appear. The first photo, blurry, shot with a phone from a monitor screen. Enthusiasts quickly identify the source. It's a screenshot from the Stellarium Planetarium program showing a comet simulation based on orbital data, not a real photograph, a computer model. The second image, where the nucleus is replaced with a CGI ship, reverse image search leads to a frame from the movie Arrival, released in 2016, an outright fake. The third photo with a cross-shaped artifact, it's a real amateur shot, but the cross is caused by diffraction spikes from a bright star that happened to be in the frame near the comet. A classic optical effect known to any astrophotographer. The fourth image, hyper-realistic, created by a neural network, confirmed by characteristic signs of AI generation, blurry texture at the edges, illogical lighting, absence of noise typical for real photographs. By Sunday noon, in the astronomical community, the leak was already perceived as another fake. But beyond that community, among the general public, the story continued to live. Because debunking never spreads as fast as a sensation. A sensation captures emotions. Debunking requires thought, analysis, willingness to reconsider the initial impression. And on top of everything, many people don't want the story to be false. They want to believe in the extraordinary, in mystery, in the idea that beyond our planet exists something greater than rocks and ice. Sunday noon, October 26th. At the European Space Agency headquarters in Darmstadt, Germany, the workday begins for public relations specialists. Email is overflowing with journalist inquiries. Social media is burning with discussions of the leak. Phones ring non-stop. One question: is it true that 3I Atlas is not a comet? Is the agency hiding information? Do secret images exist showing something else? ESA staff are used to such situations. Every few years, a new conspiracy wave appears. The face on Mars, pyramids on the moon, the alien probe Oumuamua, now a ship disguised as a comet. The action protocol is well rehearsed. First, calm. Second, facts. Third, transparency. The agency prepares an official statement. By 3 o'clock, Central European Time, a press release appears on the ESA website. Neutral headline: clarifications regarding images of interstellar Comet 3I Atlas. Text is short, clear, without emotion. The agency confirms all images of the comet taken by European Space Agency spacecraft have been published in open access. There were no leaks. No secret images exist. The images circulating on social media as a leak are either not real photographs or represent amateur shots with incorrect interpretation of artifacts. The press release then lists official data sources: Hubble Space Telescope archives, James Webb Space Telescope database, images from Mars Express, and Trace Gas Orbiter spacecraft. All data is available to anyone. Website addresses, download instructions, complete transparency. But ESA's statement is just the beginning. By Sunday evening, NASA joins in. The space agency's official Twitter account publishes a thread of 8 posts. The first post repeats the main point. 3I Atlas is a comet. All data is open. The leaks are false. The following posts are educational. They explain how space photography works, why bright objects create halos, what diffraction spikes are, how sensor noise forms random patterns. Each explanation is accompanied by examples, comparison of images of the same comet with different exposure settings, demonstration of the overexposure effect on real images of other comets. The last post contains an appeal. Science is open to everyone. Check sources, ask questions, but remember, extraordinary claims require extraordinary evidence. A quote from Carl Sagan, astronomer and science popularizer who passed away in 1996. Meanwhile, science journalists begin publishing detailed analyses. One of the largest popular science portals releases an article titled, "Why 3I Atlas is Not an Alien Ship, Point-by-Point Analysis." The article analyzes each leaked image in detail. The first photo, a Stellarium screenshot, confirmed by file metadata and the program interface visible at the frame edges. The second, a movie frame, easily verified by reverse image search. The third, a real amateur shot, but the cross is simply a diffraction spike from a bright star. The journalist provides an example. All images taken by the James Webb Space Telescope show bright stars with 6-pointed rays. This isn't mysticism. This is physics. Light passing through the hexagonal segments of the telescope's primary mirror creates a diffraction pattern. The fourth image, created by a neural network, is given away by characteristic signs: too perfect texture, unrealistic lighting, absence of a star background. But the most convincing refutation comes from an unexpected source. Sunday evening, an amateur astronomer from Australia, having access to a 250mm telescope and a professional astronomical camera, publishes his own images of 3I Atlas taken that same night. High resolution, proper calibration, dark frame subtracted, flat frame eliminated, hot pixels removed. The image clearly shows a green coma, elongated nucleus, thin tail, no ships, no geometric structures, an ordinary comet, beautiful, bright, unusual in its interstellar origin, but still a comet. The astronomer attaches a complete description of the shooting and processing process, telescope parameters, exposure time, filters used, processing software. Anyone can repeat the observation and get a similar result. This is the essence of science: reproducibility. By Monday, October 27th, professional astronomers joined the discussion. Several major observatories published their own high-resolution images of 3I Atlas. La Silla Observatory in Chile, where the Atlas system that first discovered the comet is located. Mauna Kea Observatory in Hawaii. Kitt Peak Observatory in Arizona. All images show the same thing: a comet. Spectral analysis confirms chemical composition: water ice, carbon dioxide, ammonia, methane, cyanogen, diatomic carbon. Classic comet cocktail. Nucleus rotation speed, 48 hours per revolution. Trajectory, hyperbolic, but fully explained by gravitational influence of the sun and planets. No anomalous accelerations, no course changes. The object behaves in exact accordance with Newton's laws of celestial mechanics. Particularly important are images obtained by spacecraft in Mars orbit. October 3rd, 2025. The comet passes at a distance of 30 million kilometers from Mars, the closest approach to any of humanity's spacecraft. The Trace Gas Orbiter probe, a joint mission of the European Space Agency and Russia's Roscosmos, turns its CASS camera toward the comet. The camera is designed to photograph the Martian surface from a distance of 400 kilometers. The comet is thousands of times farther and tens of thousands of times dimmer. Engineers aren't sure if they'll see anything at all. But they try. A series of long exposure shots. The first frames arrive on Earth several hours later. Quality is poor. Noise is high. But the images show a slightly blurred white dot slowly moving among the stars, the comet's nucleus and coma, indistinguishable at such distance, merged into one spot of light. But the movement, trajectory, brightness, everything matches the calculations. Nicholas Thomas, professor of experimental physics at the University of Bern, head of the CASS team, gives an interview to a Swiss newspaper. This was a very difficult observation for our instrument, he admits. The comet is about 10 to 100,000 times dimmer than our usual target. Honestly, I'm surprised it turned out so well. He explains, distinguishing the nucleus and coma at such distance is impossible. It's like trying to see a mobile phone lying on the moon's surface from Earth. Physical limits of optical resolution. But the very fact of detection and trajectory confirmation is a success. The images are published on the ESA website in the ExoMars mission section. Next to the photos, detailed technical description, shooting parameters, lighting conditions, distance, no secrets, no omissions. The second Martian spacecraft, Mars Express, also makes an attempt. The JWST camera, high-resolution stereo camera, captures several frames of the comet between October 2nd and 7th. Quality is even lower than CASS's. The comet is barely distinguishable against the noise, but it's there. The European Space Agency publishes even these unsuccessful images because transparency is the foundation of trust. If you hide failures, people start suspecting you're hiding successes too. But if you publish everything, both successful and less successful observations, a complete picture forms. Science isn't always beautiful. Sometimes data is noisy. Sometimes the object is too dim. Sometimes instruments can't cope. But that's normal. That's the process. By midweek, October 30th, the leak begins to lose momentum. Too many refutations. Too much real data. Too many people independently confirming 3I Atlas is a comet. But part of the audience continues to believe. For them, refutations are part of the conspiracy. Of course, NASA and ESA will deny it. They can't afford to cause panic. Professional astronomers depend on grants. They'll say what they're told. Amateur images can be faked. How do we know they're real? The logic of conspiracy thinking is self-enclosed. Any evidence against the theory is interpreted as evidence for it. Because if the conspiracy is so powerful, it controls all the world's space agencies, then it can fake any data. And the more refutations, the stronger the conspiracy. But for most people open to facts, the picture becomes clear. The leak was a combination of several factors. Real amateur shots with artifacts, interpretation errors of these artifacts by people unfamiliar with space photography, several outright fakes created to attract attention or simply as a joke, spread through social media where sensation spreads faster than verification, and the desire to believe, the psychological need for a miracle, for mystery, for confirmation that we're not alone in the universe. This need is so strong that people are willing to see alien ships in blurred pixels, ignoring all rational explanations. Interestingly, Comet 3I Atlas itself really is unusual, not because it's a ship, but because it's a visitor from interstellar space. It formed in another star system, possibly billions of years ago, traveled through the cold void between stars for hundreds of thousands, maybe millions of years, randomly entered the sun's gravitational field, and for a brief moment, a few months, crossed our system before heading back into the abyss. We'll never know exactly where it came from. Backward trajectory calculations give only a direction, a region in the constellation Hercules, but stars move, and over millions of years the original parent star could have gone far away. This is a ghost from another world, a message written not by intelligence, but by nature. And it's no less amazing than any fictional spaceship. October 29th, 2025. The comet passes perihelion, the closest point to the Sun, 203 million kilometers, just beyond Mars's orbit. Brightness reaches its peak, plus 14.6 stellar magnitude, still too dim for naked eye observation, but accessible to small amateur telescopes. Thousands of amateur astronomers around the world point their instruments at the comet. Photos fill specialized forums. Each image is a small testimony. 3I Atlas exists. It's real. It's visible. And it's a comet. Thousands of independent observers, unconnected to each other, not receiving orders from governments or space agencies, all see the same thing. If this is a conspiracy, it must include every person on the planet who has a telescope, which is absurd. November 1st, 2025. Friday. A week has passed since the leak appeared. In the scientific community, the topic is already closed. Refutations published, data verified, conclusions drawn. 3I Atlas is a comet, no doubt, but in certain segments of the internet, the discussion continues. Forums dedicated to ufology and conspiracy theories are filled with messages. The official version is unconvincing. Too many coincidences. They want us to calm down. These people aren't stupid. Many of them are educated, well-read, capable of logical thinking. But something in their psychology, in the structure of their perception of the world, makes the conspiracy interpretation more attractive than the scientific one. Why? This question has occupied psychologists and sociologists for decades. Let's start with a basic human instinct: pattern seeking. Our brain evolved in an environment where the ability to find patterns meant survival. A rustle in the bushes could be wind, or it could be a predator. Those of our ancestors who assumed a predator and were wrong lost a bit of energy on unnecessary caution. Those who assumed wind and were wrong lost their lives. Natural selection favored the cautious, those who saw patterns even where there were none. This is called agent detection, the tendency to attribute random events to the presence of an intelligent agent, intention, plan. When we see a series of coincidences, the brain automatically seeks an explanation in terms of someone's actions, not chance, not statistical probability, but someone deliberately arranged this. Conspiracy. The second factor, the need for control. The world is chaotic. Events happen randomly, unpredictably, without any plan. This is frightening. Awareness of one's own insignificance in the face of blind forces of nature, randomness, entropy, is psychologically uncomfortable. Conspiracy theory offers an alternative. Yes, bad things happen in the world, but not randomly. Someone controls what's happening. A secret group, government, corporations, aliens. Paradoxically, this worldview is more comforting. Because if someone is in control, then there's order. There's a plan. Maybe sinister, but a plan. And if there's a plan, it can be uncovered, understood, possibly opposed. This gives an illusion of control. Randomness gives nothing. Before randomness, we're powerless. The third factor, social identity. Belonging to a group of like-minded people sharing secret knowledge creates a sense of being chosen. We know the truth that others don't see. We're not sheep following the herd. We think critically, unlike the naive who believe the official version. This forms identity, raises self-esteem, creates a sense of community. Online conspiracy communities function like tribes, with their own language, their own rituals, their own heroes and enemies. Leaving such a community means not just changing your opinion about some fact. It means betraying your group, losing friends, losing part of your identity. The psychological cost is too high. The fourth factor, cognitive dissonance and the backfire effect. When a person encounters information contradicting their beliefs, discomfort arises. Cognitive dissonance. The brain seeks a way to eliminate this discomfort. One path, revise the belief. Another, reject the contradicting information. The second path is psychologically easier, especially if the belief is tied to identity. Moreover, attempting to refute a belief with evidence can trigger the backfire effect. The person doesn't just reject the evidence, but becomes even more entrenched in their position. Refutations are perceived as an attack on their personality, their group, their worldview. The defensive reaction kicks in automatically. The fifth factor, distrust of authorities. In recent decades, trust in institutional science, governments, media has declined. Partly, this is justified. History knows examples when official structures lied, hid information, manipulated public opinion. Tobacco companies for decades denied the link between smoking and cancer, funding controlled studies. Pharmaceutical corporations hid drug side effects. Governments conducted secret experiments on their own citizens, like Project MK Ultra in the US, or radiation experiments in the Soviet Union. These real conspiracies created grounds for distrust. If they lied then, why wouldn't they lie now? The logic is understandable, but it leads to another extreme: total skepticism, where any official statement is automatically considered a lie. The history of space exploration is full of moments when this distrust manifested particularly strongly. The most famous example: moon landing denial. Despite the fact that Apollo flights are documented by thousands of photographs, hours of video recordings, hundreds of kilograms of lunar soil analyzed by independent laboratories around the world, including the USSR, part of the population continues to believe in falsification. The main arguments of conspiracy theorists have long been debunked. Photos don't show stars, because the short exposure necessary to photograph the bright lunar surface doesn't capture dim stars. The flag waves in a vacuum. The flag doesn't wave, it ripples from inertia after the astronaut installed it and let go. Shadows fall in different directions. Uneven terrain creates such an effect. Each objection has a simple explanation, but conspiracy theorists continue to repeat them. Interestingly, moon landing denial is distributed unevenly. Polls show that in the US, about 6% of the population consider the landings faked. In Russia, the figure is higher, about 25%, according to some data. Why? Historical legacy of the Cold War. Soviet propaganda didn't deny the landings openly, but created an atmosphere of distrust toward everything American. After the collapse of the USSR, when control over information weakened, this atmosphere transformed into conspiracy theories. Paradoxically, the country that monitored American flights with its own means and confirmed their reality now has a high percentage of deniers. This shows that conspiracy beliefs are often connected not with facts, but with socio-cultural context. Another example: Martian canals. Late 19th century. Italian astronomer Giovanni Schiaparelli observes Mars through a telescope and sketches thin lines crossing the planet's surface. He calls them canali. In Italian, this simply means channels or grooves, a term without indication of artificial origin. But when translated to English, the word becomes canals, artificial canals. American astronomer Percival Lowell picks up the idea and develops an entire theory. Martians built a global network of canals to transport water from polar caps to the equator to save the dying planet from drought. Lowell publishes books, gives lectures, builds an observatory in Flagstaff, Arizona, specifically to study Mars. The public is enchanted by the idea of Martian civilization. Writers create dozens of novels about Mars, but as telescopes improved, it became clear there are no canals. What Schiaparelli and Lowell saw was an optical illusion. The human brain connected random dark spots at the limit of visibility into lines. When spacecraft began photographing Mars from close range, no canals were found. Instead, craters, volcanoes, canyons, dry riverbeds of ancient rivers, but not a global network of straight lines. Lowell's theory collapsed, but it left a trace in culture. The image of Mars as a dying planet with an ancient civilization became an archetype of science fiction, returning to 3I Atlas. The leak of October 25th wasn't an isolated incident. It fits into a long history of false alarms and premature claims about extraterrestrial life or technology. In 1996, a group of scientists announced they found traces of fossilized bacteria in Martian meteorite ALH 84001. The news went around the world. U.S. President Bill Clinton made a statement. "If this is confirmed, it will be one of the greatest discoveries in the history of science." But subsequent studies showed that the structures taken for bacteria most likely have a non-biological origin. There's no consensus to this day, but most scientists are skeptical of the biological interpretation. In 2003, astronomers discovered a radio signal called SHGB 02+14a, a narrowband signal coming from the area between the constellations Pisces and Aries, was detected as part of the SETI at Home project. Some media announced possible contact with extraterrestrial intelligence, but further observations didn't confirm the signal. It never repeated. Most likely, it was an artifact or signal from a terrestrial source accidentally reflected by a space object, or simply a statistical fluctuation in the data. When you analyze billions of signals, false positives inevitably appear. In 2015, the Kepler telescope recorded strange brightness fluctuations of star KIC 8462852, also known as Tabby's star, after astronomer Tabitha Boyajian, who discovered the anomaly. The star's brightness dropped by 22%, inexplicably much for a planet transit. The drops were irregular, asymmetric. Journalist Ross Anderson published an article in The Atlantic magazine where he mentioned a hypothesis proposed by astronomer Jason Wright. Possibly, this is a megastructure built by an advanced civilization, a Dyson sphere or its fragments surrounding the star to collect energy. Media immediately picked it up. Scientists discovered alien megastructure, but further observations showed most likely, the cause is a dust cloud or swarm of comets periodically passing in front of the star. Natural explanation, not requiring aliens. Each of these cases shows the same dynamic: discovery of an anomaly, preliminary hypothesis, including the possibility of an extraordinary explanation, media attention exaggerating the probability of the extraordinary option. Spread through social media, formation of expectations, then further research showing a mundane explanation, publication of refutations. But by this point, public attention has already switched to the next topic. The refutation doesn't get the same coverage as the original sensation. As a result, many people are left with the impression that there was something there, although scientific consensus is unambiguous. What distinguishes the scientific approach from the conspiracy one? Openness to revision. Science isn't afraid to be wrong. The scientific method is built on constant testing and revision of theories. A hypothesis is proposed, tested. If data contradicts, it's discarded or modified. This is normal. This isn't weakness, but strength. Conspiracy thinking works the opposite way. A hypothesis is accepted immediately, emotionally, as a belief. All subsequent data is interpreted through the prism of this belief. Confirming data, accepted. Refuting data, discarded as part of the conspiracy. Such a thinking system is self-enclosed. It's irrefutable, not because it's true, but because it's designed to be irrefutable. But there's another aspect. Behind conspiracy theories often lies deep humanity, desire for a miracle, hope that we're not alone in the universe, that there exists something greater than our small planet with its problems and conflicts. Comet 3. I-Atlas is real. It really came from interstellar space, from another star system. This is already a miracle in itself. It carries matter formed billions of years ago under conditions different from our solar system. Studying it, we learn about the diversity of space, about processes occurring in other parts of the galaxy. This is no less amazing than any fictional ship. But a miracle requires patience, attentiveness, willingness to look calmly, without bias, And that's harder than believing in a sensation. November 5th, 2025, Wednesday. 10 days have passed since the leak appeared. In schools and universities around the world, teachers are using this story as an educational example, a media literacy lesson. How to verify information in an era when anyone can publish anything, and sensation spreads faster than truth. This isn't just an academic exercise. The ability to distinguish reliable information from disinformation is becoming a vital skill, not only in the context of space exploration. In matters of health, politics, economics, climate, the world is drowning in information, and the ability to filter this flow determines the quality of our decisions, our beliefs, our lives. The first and simplest question when encountering any claim: who is the source? In the case of the 3I Atlas leak, the source was an anonymous user on a Japanese social network. No name, no verification credentials, no publication history. Anonymity on the internet has its value. It protects people living under repressive regimes, allows free expression without fear of persecution. But anonymity also eliminates accountability. A person without a name can say anything without consequences. Therefore, the first rule: an anonymous claim requires especially thorough verification. It cannot be accepted on faith simply because it's published. The second question: what evidence is provided? In the case of the leak, there were several images, but an image by itself isn't proof. Photos can be edited, generated, taken out of context. A critical approach requires asking, where did this image come from? Who made it? When? Under what conditions? Is there metadata embedded in the file? Modern digital photographs contain EXIF data: date, time, camera model, shooting parameters, sometimes even GPS coordinates. This data can be removed, but its presence or absence is already informative. Professional photographers and scientific organizations usually preserve metadata. Anonymous leaks often remove it. The third verification tool: reverse image search. Services like Google Images, Yandex Images, TinEye allow you to upload a photo and find all its appearances on the internet. If a unique leak is actually taken from a movie published 3 years ago, reverse search will show it. If the image appeared for the first time on that specific day and only on that account, it doesn't prove authenticity, but at least excludes the simplest fake: theft of someone else's content. In the case of 3I Atlas, reverse search quickly revealed the sources of several leaked photos: a movie frame, a planetarium program screenshot, AI generation. The fourth step: comparison with official sources. If it's about a space object, publicly accessible databases exist. The Hubble Space Telescope archive contains all scientific images taken by the instrument over 35 years of operation. Anyone can go to the website, enter the object's coordinates or name, download raw observation files. Same with the James Webb Telescope. The European Space Agency publishes data from all its missions. NASA has open access to archives. This isn't secret data available only to scientists. This is common human heritage, paid for by taxpayers and provided to everyone. If someone claims that real footage differs from official data, the first question is, how do you know? Did you see the originals? Where? Show the source. The fifth principle: extraordinary claims require extraordinary evidence. This phrase was popularized by American astronomer Carl Sagan, though the idea goes back to 18th century philosopher David Hume. The essence is simple. The more improbable the claim, the more convincing the evidence must be. The claim, "I saw a cat on the street," doesn't require serious proof. Cats are common. Thousands of people see them daily. The claim, "I saw a dragon on the street," requires photos, video, independent witnesses, physical traces, because dragons don't exist in ordinary experience. The claim, "An interstellar comet is actually an alien ship," is extraordinary. We've never observed alien technology. We have no confirmed examples. Therefore, evidence must be exceptional. A blurry photograph of unknown origin isn't sufficient. The sixth aspect, understanding how science works. Science isn't perfect. Scientists make mistakes. Theories are revised. But science has built-in self-correction mechanisms. Peer review, when independent experts check an article before publication. Reproducibility, when other laboratories repeat the experiment and get the same results. Data openness, when original observations are available for analysis by anyone. These mechanisms don't guarantee absolute truth, but they minimize the probability of systematic error or deception. If one scientist claims a revolutionary discovery, but others can't reproduce it, the discovery isn't accepted. If data is classified and unavailable for verification, the scientific community treats the claim skeptically. Transparency is the foundation of trust. The history of science shows this approach works. Cold fusion. In 1989, chemists Martin Fleischmann and Stanley Pons announced they achieved nuclear fusion at room temperature in a simple electrolytic cell. If this were true, the energy crisis would be solved. The world exploded with news. But when other laboratories tried to reproduce the experiment, nothing worked. No excess heat, no fusion. It turned out Fleischmann and Pons made errors in measurements and interpretation. Their claim was rejected by the scientific community. The system works. Error identified, truth restored. Or Andrew Wakefield's vaccine and autism. In 1998, British physician Andrew Wakefield published an article in the prestigious medical journal The Lancet, claiming a link between the MMR vaccine against measles, rubella, and mumps, and autism in children. Parents panicked. Vaccination rates dropped. Measles outbreaks began. But other researchers couldn't find any connection. Moreover, journalistic investigation revealed that Wakefield falsified data, had a financial conflict of interest, and violated ethical norms. The article was retracted. Wakefield lost his medical license, but damage was done. The anti-vaccination movement, based on his false data, continues to exist 2 decades later, despite hundreds of studies refuting the vaccine autism link. These examples show 2 things. First, science is capable of correcting errors, but it takes time. Second, even after refutation, false beliefs can persist in society, especially if they emotionally resonate with people. Fear for a child's health is stronger than statistics. Desire to believe in aliens is stronger than spectral analysis. Therefore, media literacy isn't just information verification skills, but emotional resilience. The ability to separate what's desired from what's real. Willingness to accept boring truth instead of exciting fiction. The 7th principle, multiple sources. 1 piece of evidence can be an error. 2, a coincidence. 10 independent pieces of evidence, obtained by different methods, in different places, by different people, all pointing to the same thing. This is the foundation for confidence. In the case of 3I Atlas, thousands of amateur astronomers around the world observed the object. Several space telescopes photographed it. Martian probes captured its flyby. Spectral data was obtained by dozens of observatories, all independently confirmed a comet. If this were a conspiracy to hide an alien ship, it would require coordinating the actions of tens of thousands of people in hundreds of organizations in dozens of countries, many of which are politically hostile to each other. The probability of such a conspiracy approaches zero. The eighth tool: healthy skepticism toward leaks and insiders. Real leaks of secret information do happen. Edward Snowden revealed NSA mass surveillance programs. Chelsea Manning transmitted secret military documents to WikiLeaks, but these leaks were accompanied by massive arrays of verifiable documents, specific names, dates, facts. They weren't anonymous claims with blurry photos. A real whistleblower risks freedom and life, therefore provides the most convincing evidence possible. A false informant risks nothing and can afford to be vague. My friend working at a university isn't a source. It's a rumor. The ninth aspect: understanding motivation. Why is someone spreading certain information? In the case of real scientific discoveries, the motivation is clear. Scientists want recognition, publications, grants. They sign their articles, indicate affiliations, provide contacts. In the case of anonymous leaks, motivation is unclear. Perhaps the person is sincerely mistaken and shares what they consider important. Perhaps it's trolling, a joke, a desire to see how people react. Perhaps it's a way to attract attention to their account, gain followers, monetize traffic. Social media rewards viral content. Sensation brings views. Views convert to money. The economic incentive to create fakes is enormous. The 10th and perhaps most important skill: the ability to acknowledge uncertainty. Sometimes we don't know. This is normal. Not every question has an immediate answer. The scientific method includes the phrase, "Further research is needed." This isn't weakness. This is honesty. Pseudoscience and conspiracy theory always offer simple, definitive answers. It's definitely a ship. They're definitely hiding it. We know the truth. Real science is more cautious. Data indicates. Probably. With a 95% confidence interval. Uncertainty is psychologically uncomfortable, but the world is complex, and simple answers are often wrong. November 11th, 2025, a media literacy teacher in a Moscow school conducts a lesson using the 3-Eye Atlas story. She shows students the leaked images and asks them to analyze. 16-year-old teenagers who grew up with the internet quickly identify the fakes. Reverse search, metadata verification, comparison with official sources. One student finds the original post where the leak began. Another student downloads real images of 3-Eye Atlas from the Hubble archive and compares them with the fakes. The differences are obvious. The lesson concludes with a discussion. Why do people believe such stories? The class reaches a conclusion. Because they want to. Because it's interesting. Because an ordinary comet is boring and an alien ship captures the imagination. The teacher smiles. Awareness of one's own bias is the first step to critical thinking. Psychological research shows people with higher education levels are less likely to believe in conspiracy theories, not because they're smarter, but because education develops specific skills: source analysis, logical thinking, understanding of probability and statistics, the ability to hold several hypotheses in mind simultaneously and weigh their relative merits. These skills aren't innate. They're cultivated. Schools, universities, popular science media all play a role in forming a society resistant to manipulation. But this process is slow, requires patience, investment in education, society's willingness to value truth over sensation. Comet 3-Eye Atlas continues its journey. By mid-November, it had moved 250 million kilometers from the sun. Brightness is falling. The coma is shrinking. The tail is shortening. In a few months, it will become too dim for observation, even by large telescopes. In another year, it will cross Jupiter's orbit and begin the final stretch toward the solar system's edge. In a decade, it will leave the heliopause, the region where solar wind yields to interstellar space. It will return to the cold void from which it came. Will travel millions of years until it randomly enters another star system, or collides with something, or evaporates completely under cosmic ray exposure. We'll never know its fate. But those few months it spent in our system left a mark, not in the form of an alien message, in the form of scientific data, thousands of images, spectra, trajectory measurements, knowledge we added to our understanding of the universe, and a lesson about how important it is to distinguish truth from the desire to believe. November 15th, 2025. Sunday. 3 weeks since the leak appeared. In search engines, queries for 3I Atlas ship are dropping daily. The Google Trends graph shows a sharp peak on October 25th and a smooth decline afterward. By mid-November, interest has returned to baseline levels. News sites have switched to other topics. Social media has filled with new sensations. The nature of the information space is such. Attention is a limited resource. Each day brings dozens of new stories demanding emotional response. Yesterday's sensation becomes today's past. The life cycle of a viral story is predictable. Explosive growth, plateau of maximum attention, refutations, fade, oblivion. But oblivion is incomplete. In the depths of the internet, on specialized forums dedicated to ufology and conspiracy theories, discussions continue, not with previous intensity. Every few days, a new message appears. Someone shares additional information. Someone proposes an alternative data interpretation. Someone claims the refutations are unconvincing. These discussions form what researchers call the long tail of a conspiracy story. The main wave has passed, but residual beliefs persist in certain communities. There, they become part of collective memory, the group's mythology. Remember that comet in 2025? They never explained all the inconsistencies. The fact that there were no inconsistencies is no longer important. The story has acquired its own life, detached from reality. For the scientific community, the 3I Atlas story has completely different meaning. The comet continues to be studied. November 20th, a research group from the European Southern Observatory publishes an article in the journal Astronomy and Astrophysics. The title is technical: Spectroscopic Analysis of Volatile Components of Interstellar Comet 3I Atlas, based on very large telescope observations. The article contains detailed analysis of the coma's chemical composition: molecules of water, carbon monoxide, methane, ammonia, hydrogen cyanide, formaldehyde detected. The ratios between these components differ from typical solar system comets. Elevated carbon monoxide and methane content suggest formation in a colder environment. The temperature of the protoplanetary disk where this comet was born was probably lower than in our system. This indicates greater distance from the parent star or a less massive star. The second discovery: isotopic composition. The deuterium to hydrogen ratio in water molecules turned out higher than in our system's comets. Deuterium is a heavy isotope of hydrogen, with 1 proton and 1 neutron in the nucleus instead of 1 proton. Its quantity depends on formation conditions. Elevated deuterium content indicates cold, possibly more primitive matter that preserved the isotopic composition of the primordial molecular cloud. This information is invaluable for understanding the diversity of planetary systems. Each star forms under unique conditions: temperature, density, chemical composition of surrounding gas. All these parameters influence what planets and comets will appear. Studying interstellar objects, we get direct samples of matter from other systems. It's like receiving a letter from a distant world without having to fly there. The third observation: dust. Spectral analysis shows the presence of silicate particles, organic compounds, possibly ice crystals. Particle size varies from fractions of a micron to several millimeters. Large particles form a second type of tail, broader and more curved, distinct from the gas tail. This is a dust tail, created by solar light pressure. Photons, striking dust particles, transfer momentum to them, pushing them away from the sun. Light particles accelerate faster, heavy ones slower, creating a fan. From the shape and brightness of the dust tail, you can determine particle properties. This is archaeology at a distance. We can't take a comet sample in our hands, but we can study the light reflected and emitted by its matter and reconstruct composition, structure, history. By late November, enough data had accumulated for the first comprehensive report. The International Astronomical Union organizes an online symposium dedicated to interstellar objects. Hundreds of scientists from dozens of countries connect to the stream. Presentations follow one after another: trajectory analysis, photometry, spectroscopy, polarimetry, measurement of polarization of light reflected by dust, which gives information about particle shape and composition. Each presentation is a small brick in the large building of understanding. Science works slowly. One observation doesn't make a discovery. Multiple independent confirmations are required, careful verification, agreement with existing theories, or, if there's no agreement, revision of theories. This is a process stretched over months, years, sometimes decades. One presentation is devoted to rotational dynamics. Astronomers from the California Institute of Technology observed brightness changes of the comet with a periodicity of approximately 48 hours. This is the rotation period of the nucleus around its axis. But the amplitude of changes is small, only about 10%. This indicates that the nucleus is either nearly spherical or rotating around an axis directed close to the line of observation. The first option is more likely: spherical or slightly elongated shape, not a cigar like Oumuamua. This removes one of the anomalies that lovers of extraordinary interpretations used as an argument. Unusual shape, sign of artificiality. But the shape turned out to be ordinary. Another presentation analyzes the absence of anomalous accelerations. The trajectory of 3I Atlas precisely corresponds to celestial mechanics predictions, accounting for the sun's and planet's gravity. The only non-gravitational acceleration is caused by the reactive force of outgassing, evaporation of volatile substances from the surface. This acceleration is small, constitutes fractions of a percent of gravitational, and is fully explained by comet activity models. No maneuvers, no course changes. The object moves like a chunk of ice with rocks, obeying Newton's laws. This is another refutation of hypotheses about artificial origin. A spaceship, even non-functioning, would have different properties. Metal, ceramics, composite materials reflect light differently than ice and silicates. The spectrum would be different. But the spectrum of 3I Atlas is typically cometary. The symposium concludes with a summary. A professor from Leiden University in the Netherlands, a specialist in solar system small bodies, summarizes: Comet 3I Atlas is the third confirmed interstellar object and the first interstellar comet after Borisov. Its chemical composition, physical properties, dynamics, fully correspond to natural origin. No anomalies requiring extraordinary explanations have been found. The object represents enormous scientific interest as a sample of matter from another planetary system. Observations will continue as long as brightness allows. We plan to track the comet until spring 2026, after which it will become too dim, even for the largest telescopes. Applause in the chat. Conference closes. Scientists return to their research. For the general public, these presentations remain invisible. Scientific articles are published in specialized journals, accessible by subscription or for a fee. The language is technical, overloaded with terms incomprehensible to non-specialists. Conclusions are cautious, formulations blurred with probabilities and confidence intervals. This isn't a format for mass consumption. Science journalism tries to translate these results into understandable language, but rarely with the same resonance as the original sensation. An article in Science News headlined, "Interstellar Comet 3. I-Atlas turned out to be exactly a comet," gets several thousand views. The article, "Leak Shows Ship Instead of Comet 3 weeks ago," got millions. A symmetry of attention. December 1st, 2025. A month has passed. The comet has moved 300 million kilometers from the Sun beyond Mars's orbit. Brightness dropped to 16th stellar magnitude. Invisible to the naked eye. Accessible to medium-sized telescopes. Amateur astronomers continue to photograph, though each week it becomes harder. Longer exposures required. More patience. The comet transforms from an object of mass interest into a target for enthusiasts, those who are genuinely interested in astronomy, not sensations. Continue observing. For them, it's not a disappointment that the comet turned out to be a comet. It's a miracle in itself, a visitor from another star system, visible in their own telescope, in the backyard of their home. Connection with space, immediate, personal. December 10th. On one of the Russian-language astronomy forums, a user publishes a post. Today, possibly the last time I photographed 3I Atlas, 200mm telescope, 10-minute exposure, barely distinguishable against the noise. In a week, my instrument won't cope. Goodbye, Comet. Thanks for stopping by. Under the post, dozens of comments. Other astronomers share their images, observation memories. Someone saw it for the first time in August. Someone observed all October. Someone only managed to catch it in November when they learned of the comet's existence. This is community. People sharing not conspiracy theories, but love of the sky. They're not disappointed by the absence of aliens. They're awed by reality. Rock and ice from another world, flying past our planet once in millions of years. How can you not be amazed by this? But memory of the leak will remain. Years from now, when the next interstellar object is discovered, someone will remember with 3I Atlas, there was that story about a ship. And a new cycle may begin again, because human psychology doesn't change quickly. Desire for a miracle, attraction to mystery, willingness to believe in the extraordinary. These qualities are deeply rooted. They're part of what makes us human. Imagination, hope, dream. Without them, we wouldn't create art, literature, wouldn't explore space. But the same qualities make us vulnerable to manipulation, deception, self-deception. Balance between openness to the new and critical thinking is what each generation must learn anew. The scientific lessons of 3I Atlas will be analyzed for years. Articles will continue to appear in 2026, 27, 28. Doctoral dissertations will be defended based on this data. Young scientists will build careers studying matter from another star system. But the social lessons, how society reacts to unusual phenomena, how disinformation spreads, how mechanisms of trust and skepticism work, these lessons are perhaps more important, because the next sensation is inevitable, the next leak, the next secret document, the next proof of something extraordinary. The question isn't whether they'll appear. The question is how we'll react to them. Will we preserve the ability to distinguish reliable from desired? Will we maintain balance between skepticism and curiosity? Comet 3. I-Atlas continues its journey in the cold darkness beyond Mars. In a few months, it will cross Jupiter's orbit. In a year, Saturn's orbit. In 5 years, it will reach the Kuiper Belt region, where the Sun is already almost indistinguishable from other stars. In 10 years, it will leave the heliopause and return to interstellar space. It will fly millions of years in silence and cold until the gravity of another star captures it or deflects its trajectory. Perhaps in 1 billion years, it will fly into another system, where intelligent beings, if they exist, will see in telescopes a strange comet that came from the depths of space, and perhaps they too will have rumors, their versions of leaks, their debates between science and fantasy. Because this is probably a universal property of mind, to see more than there is, and to dream of the impossible. And there's nothing wrong with that, as long as we remember where dream ends and reality begins. December 22nd, 2025, Monday. Winter solstice just passed. Nights are long, ideal for astronomical observations. In a small town in New Zealand, where the population barely reaches 3,000, 52-year-old physics teacher David Mackenzie is packing up his telescope. Last time. Comet 3. I-Atlas has become too dim. Even his instrument, 280 millimeters aperture, a decent amateur system, can no longer capture its light. He photographed the comet 143 nights in a row, from August to December, every clear night when weather permitted. Got up at 3 in the morning, set up equipment, pointed at coordinates, took a series of exposures 10 minutes each, processed data, subtracted noise, averaged frames, published results in the International Database of Amateur Astronomers. 143 nights. This isn't just a hobby. This is dedication. Mackenzie remembers learning about the leak on October 25th. Students at school were discussing it during break. "Mr. Mackenzie, you're following the comet. Is it true it's a ship?" He smiled, explained calmly, without judgment, showed his own images on the computer, talked about artifacts, about overexposure, about how the human brain sees patterns where there are none. Some students nodded, understanding. Others looked disappointed. One boy said, "But it would be cool if it was a ship." Mackenzie agreed. Yes, it would be cool, but reality is cool too. This is a comet from another star system. We're observing a piece of a world that formed around another sun. Isn't that a miracle? The boy thought about it, then asked, "Can I look through your telescope?" Since that evening, 3 students started coming regularly to night observations. In a Moscow suburb, in a 9-story panel Khrushchev-era building, 65-year-old retiree Gennady Petrovich Solovyov sits by the window. The telescope on the balcony was put away long ago. December frosts, -15, metal freezes, hands go numb through gloves. But he continues to look at the sky every evening. With the naked eye, just looks. 3i Atlas is there, somewhere between Leo and Virgo, invisible, moving away. He observed it in September, October, early November. His telescope is modest, only 150 millimeters, a Soviet Tal-1, produced in 1983. The mechanics are reliable, optics simple, but it works. In 42 years of ownership, he's observed thousands of objects, planets, nebulae, galaxies, hundreds of comets. But interstellar, for the first time, he missed Comet Borisov in 2019, was in the hospital, heart surgery. When 3I Atlas was discovered in July 2025, he vowed not to miss it. Solovyov doesn't participate in online discussions, doesn't post images on social media, doesn't write comments, just observes. Keeps a handwritten journal, a thick notebook with grid paper, bought back in Soviet times, pages yellowed, but quality paper. Each observation recorded in neat handwriting, date, time, coordinates, visual brightness estimate, description of coma, tail, surroundings, sketches in simple pencil. This is his way of communicating with space, personal, intimate, without intermediaries. When a friend asked why he does this, since professional telescopes photograph better, there's more data, what's the point of amateur observations? Solovyov answered, "I'm not doing it for science. I'm doing it for myself. To know that I saw with my own eyes, that I was a witness. Someday I'll die, and this notebook will remain. Maybe my grandchildren will read it. Maybe someone else. They'll know that I lived, looked at the sky, saw wonders." In Tokyo, in an apartment on the 23rd floor, 34-year-old programmer Yuko Tanaka sits at her computer. 3 monitors, all filled with code. She's developing an app for analyzing astronomical images. The idea came precisely from the story of the leak. October 25th, she saw a post on Japanese Twitter, showed colleagues at work. Half believed immediately. Discussed it all day. By evening, refutations appeared, but not everyone accepted them. One colleague continued to insist, "Official sources always lie." Yuko tried to explain, showed image metadata, reverse search, comparison with real photographs. Useless. The person didn't want to listen. She suddenly understood. The problem isn't lack of information, but lack of tools to verify it. Most people don't know how to analyze images, how to read metadata, how to search for fakes. Yuko started working on the app in her free time. User uploads a photo. The app automatically runs a series of checks, extracts XEF metadata, launches reverse search across multiple systems simultaneously, analyzes signs of AI generation, checks for editing traces, estimates probability of authenticity, result in percentages and detailed report. Not perfect. Algorithms can be fooled, but sufficient for most cases. She released the beta version in early December, downloaded 200,000 times in 2 weeks. Reviews positive. People are grateful. Finally, a simple way to check if they're being deceived. Yuko doesn't make money from the app. It's free, no ads. Her motivation is simpler, to live in a world with less lies, where verification is available to everyone, where truth doesn't require expert knowledge, only desire to know. December 25th, Christmas for those who celebrate. In Vatican City, in the Vatican Observatory office, 72-year-old Jesuit Father Marco Funes reviews email. Hundreds of letters after the 3I Atlas story. Believers write, asking, does the search for extraterrestrial life contradict faith? If we find aliens, what does it mean for Christianity? Funes answers patiently, as he's done for decades. The Vatican Observatory has existed since 1582. The Catholic Church has supported astronomical research for 443 years. Galileo was once condemned. True. A mistake for which the Church apologized. But today, the position is clear. Science and faith don't contradict each other. They answer different questions. Science, how the universe is structured. Faith, why it exists and what meaning is in that. Funes writes another response. God created the universe. The universe is enormous. Billions of galaxies, trillions of stars, countless planets. It would be strange if life existed only on one planet. Perhaps God created life in other places too. This doesn't diminish humanity's uniqueness, doesn't contradict Scripture. The Bible tells about God's relationship with people, not about the complete astronomical picture of the world. If we encounter extraterrestrial life, intelligent or not, it will be another confirmation of creation's greatness, not a refutation of faith. He sends the letter, opens the next one. The work is endless, but important. People seek comfort, understanding, a place for their faith in a world revealing ever new wonders. December 31st, last day of the year. In South Africa, at Sutherland Observatory, astronomer Sipho Mlambo finishes his shift. 4 nights in a row observed 3I Atlas through the 1.5-meter telescope. Last days when the Comet is still accessible to professional instruments. Starting next week, too dim. Data collected, sent for analysis, his work complete. He thinks about how quickly everything passed. 6 months ago, discovery. Excitement, planning observation campaign, coordination with colleagues around the world. Then months of intensive observations, October's leak, which he took with a smirk, another panic. November, December, gradual dimming. Now the end. The comet is leaving. They'll never see it again. In those few months that 3I Atlas spent in visibility, humanity learned everything it could about it. But it's not enough. Questions always remain. Mlambo was born in Soweto, a poor suburb of Johannesburg. In childhood, he didn't see stars. Light pollution, smog, constant haze over the city. First time he saw a real starry sky was at 15, when school organized a trip to the countryside. It changed his life. He decided to become an astronomer, despite all obstacles. Poor family, expensive education, few opportunities in South Africa. But he persevered. Scholarships, grants, hard work, doctoral degree from the University of Cape Town, postdoc in the Netherlands, then a position at Sutherland, one of the best observatories in the Southern Hemisphere. Now 38, a recognized specialist in solar system small bodies, and he observed an interstellar comet, a message from another world. He thinks about the children in Soweto who don't see stars now, about how many potential scientists are lost simply because they don't have the opportunity to look up and see a miracle. He teaches at the university, gives public lectures, tries to inspire the next generation. Science shouldn't be a privilege of rich countries. January 1st, 2026. New Year. In different time zones it arrives at different times, but when the last time zone, Baker Atoll in the Pacific, meets midnight, the old year is complete. 3I Atlas continues its journey, indifferent to the human calendar. It's now at a distance of 400 million kilometers from the Sun, just beyond Mars's orbit, moving at 50 kilometers per second relative to the Sun. The coma has almost disappeared. Too far, too cold for active evaporation. No tail. The object has returned to its original state, a dark nucleus, drifting alone in the void. Brightness, 18th stellar magnitude, visible only to the world's largest telescopes and only with long exposures. A few more months, and even they will lose sight of it. But memory will remain. In space telescope archives, thousands of images. In scientific journals, dozens of articles, hundreds in preparation. In databases, spectra, trajectory measurements, photometry. In personal archives of thousands of amateur astronomers, their own photographs, records, memories. In schools and universities, lessons built on this story. In the consciousness of millions of people, a vague memory of a comet that could have been a ship but turned out to be a comet. For some, disappointment. For others, a lesson. For still others, just an interesting moment, quickly forgotten in the flow of new events. But for those who really watched, who stood on cold nights at the telescope, who patiently processed data, who taught children to distinguish truth from fantasy, for them it was more. It was participation in a great human tradition. To look at the sky, to ask questions, to seek answers, not to invent convenient stories, but to find true ones, even if truth is less dramatic than fantasy, because truth is real, and reality, ultimately, is the only thing we have. January 15th, 2026. Small news item in the science section of several sites. The JWST spacecraft, Jupiter Icy Moons Explorer, completed its observational campaign of Comet 3 I-Atlas. Data obtained from November 2nd through November 25th, when the probe was on its way to Jupiter. Due to low data transmission speed, information arrived on Earth only in January. Processing will take months. Results expected by year's end. Another reminder that science is slow. Between observation and understanding lie months of painstaking work. But those who wait for sensations have already switched to other topics. Those who value science wait patiently, because they know the most important discoveries rarely come instantly. They form gradually, bit by bit, from thousands of small observations combined into a big picture. And this picture is worth waiting for. February 2026. 3 months have passed since Comet 3 I-Atlas disappeared from view even of the largest telescopes. Brightness dropped below 20th stellar magnitude. Distance exceeded 500 million kilometers from the Sun, beyond Jupiter's orbit. Activity completely ceased. Too cold, too far for volatile substances to evaporate. The object returned to the state of an inert rock. Dark, silent, invisible. Last images obtained in mid-January by the world's largest telescopes, working at the limit of their capabilities. A dim point of light, barely distinguishable against the noise. Now that's it. The observation campaign is complete. The analysis phase has begun. Thousands of gigabytes of data await processing. Hundreds of researchers have started work that will take years. At the European Space Agency, a special working group on interstellar objects is being formed. 18 scientists from 9 countries. Their task: systematize everything humanity has learned about 3 confirmed interstellar visitors: Oumuamua, Comet Borisov, 3 I-Atlas. Compare characteristics, find patterns, understand how typical these objects are for interstellar space. The working group's first meeting takes place in Noordwijk, Netherlands, conference room of the ESA Technical Center. Around a long table, astronomers, planetary scientists, dynamic specialists. On the screen, a comparison table. 3 objects, dozens of parameters: size, shape, albedo, chemical composition, speed, trajectory. Each cell in the table, the result of months of observations, complex calculations, careful verification. The first thing that becomes obvious: all 3 objects are different. Oumuamua, elongated, dark, with no signs of cometary activity, with unexplained non-gravitational acceleration. Comet Borisov, a typical comet with bright coma and tail, chemical composition close to solar system comets. 3I Atlas, an intermediate case. Cometary activity present, but chemical composition differs from our system's objects, elevated carbon monoxide and deuterium content. 3 objects, 3 different formation histories. This speaks to the diversity of planetary systems in the galaxy. There's no single type. Each star creates a unique family of planets, asteroids, comets, and from time to time, gravitational perturbations eject these objects into interstellar space, where they travel millions of years until they randomly enter another system. The second observation, frequency of visits. 3 confirmed objects in 8 years of observations. But telescopes have limited fields of view. They see only a tiny fraction of the sky. Statistical models suggest hundreds of interstellar objects pass through the inner solar system every year. Most are too small or too dim to be detected. We see only the largest, brightest, those that happen to pass close to Earth. It's like standing on a beach trying to notice all the grains of sand that waves bring to shore. You see a few, but there are billions. The galaxy is full of these wanderers, fragments of distant worlds drifting in the void. We live in a constant stream of interstellar material. We just rarely notice it. The third discovery, the importance of rapid response. Oumuamua was discovered when it was already receding. There was little time for detailed observations. Most data was collected after the fact, when the object was already dimming. With Comet Borisov, there was more luck. It was noticed several months before perihelion. There was time to prepare an observation campaign. With 3I Atlas, the situation was ideal. Discovery in early July, perihelion in late October, 4 months to prepare. This allowed coordinating the efforts of dozens of observatories, spacecraft, amateur astronomers. Result: the most complete data set on an interstellar object in history. The lesson is clear. More sensitive early detection systems are needed. Telescopes with wide fields of view, automatic search algorithms, fast alert channels. In this context, the Future Legacy Survey of Space and Time project is discussed. The Vera Rubin Observatory Telescope in Chile, whose construction is being completed. 8-meter mirror, 3,200 megapixel camera, ability to photograph the entire southern sky every 3 nights. When the system begins operation, detection of dozens of interstellar objects per year is expected, maybe hundreds. This will change the situation. Instead of 3 examples in 8 years, a statistically significant sample. The ability to study not individual specimens, but a population. Understand distribution by size, composition, orbits. Build models of how planetary systems form and evolve throughout the galaxy. Interstellar objects become a window into other worlds without having to fly there. Simultaneously, more ambitious plans are being discussed. An intercept mission. When the next interstellar object is discovered, large enough and slow enough, send a probe to it. Not just photograph from a distance, but approach. Take high-resolution images. Possibly collect a sample. Technically, this is difficult. Interstellar objects move fast, tens of kilometers per second relative to the Sun. To catch up with such an object, a probe must have enormous speed. Existing rocket technologies can barely cope. Either gravitational maneuvers around several planets are required, or new types of engines. Nuclear, ion, solar sails. ESA and NASA engineers begin preliminary calculations. Cost is estimated in billions of dollars. Development time, 10 years minimum. But if successful, the payoff will be enormous. March 2026. The scientific journal Nature Astronomy publishes a review article on Comet 3, Sud-I Atlas. 14 pages, 78 co-authors, scientists from 32 countries. Title: Characterization of the Third Interstellar Object. Comprehensive Analysis of Comet 3 I Atlas. The article summarizes all major findings: nucleus diameter 11.2 kilometers, albedo 4%, rotation period 48 hours, chemical composition, high carbon monoxide, methane, ammonia, hydrogen cyanide, formaldehyde content, deuterium to hydrogen isotope ratio 1.5 times higher than solar system comets, dust particles, silicates, organic compounds, possibly water ice, hyperbolic trajectory, eccentricity 1.08, velocity at infinity 62 kilometers per second. The article's conclusion is cautious, as proper in science. Comet 3 I Atlas demonstrates characteristics consistent with natural origin in a protoplanetary disk around another star. All observed properties are explainable by standard models of comet formation and evolution. No anomalies requiring extraordinary hypotheses have been found. The object represents significant scientific interest as a sample of matter from another planetary system and contributes to our understanding of the diversity of formation conditions in the galaxy. Not a word about alien ships. No mention of the October 25th leak. For science, this story never existed. It was an episode on social media, having no relation to real research. But in the acknowledgments section at the end of the article, there's an interesting paragraph. The authors express gratitude to thousands of amateur astronomers around the world, whose observations made a significant contribution to this work. Special thanks to educators and science popularizers who used Comet 3 I Atlas as an educational example for teaching critical thinking and media literacy. This is indirect recognition that the story had not only a scientific, but also a social dimension. The comet became a teaching example, not only for studying interstellar objects, but also for understanding how information flows work in the modern world. April 2026. At the University of California, Berkeley, a doctoral dissertation is defended. Topic: Spread of scientific misinformation on social media. The case of Comet 3 I Atlas. A 28-year-old graduate student from the communications department spent half a year analyzing how the October 25th leak spread, mutated, was refuted. She collected 1 million tweets, hundreds of thousands of Facebook posts, Reddit, specialized forums, applied social network analysis methods, built information spread graphs, identified key nodes, accounts through which the message was amplified. Her findings confirm what researchers already knew, but rarely demonstrated on such a large-scale example. Misinformation spreads faster than truth. Emotional messages get more reposts than neutral ones. Refutations never reach the same coverage as the original lie. And most important, there exist persistent communities where misinformation circulates endlessly, feeding itself despite external refutations. The dissertation offers recommendations for scientific organizations and journalists. React faster to false claims. Use the same platforms and language as misinformation spreaders, instead of academic jargon. Collaborate with popular bloggers who have audience trust. Teach media literacy in schools as a mandatory subject, on par with mathematics and language. Because in a world where everyone has access to publish information, the ability to distinguish reliable from false becomes a basic survival skill. The defense is successful. The dissertation is recommended for publication. Several universities offer the young scientist postdoctoral positions. She chooses the Massachusetts Institute of Technology, where she'll work on algorithms for automatic detection of misinformation. May 2026, 6 months after the leak. Comet 3. I-Atlas is at a distance of 700 million kilometers from the Sun, approaching Saturn's orbit. Speed relative to the Sun 58 kilometers per second. Each day it moves another 5 million kilometers away. In a year, it will cross Uranus's orbit. In 3, Neptune's orbit. In 10, it will leave the Kuiper belt and enter the Oort cloud, the outer boundary of the Sun's gravitational influence. Another 20,000 years later, it will exit beyond the Oort cloud and definitively return to interstellar space. It will fly through the void, cold, dark, alone. Millions of years without light, without heat, without change. Perhaps in a billion years, it will randomly enter the gravitational field of another star, or collide with a planet, or will fly forever until the protons in its atoms decay in an unimaginably distant future, when the universe cools and goes dark. But memory of its visit will remain, in scientific articles that will be cited for decades, in astronomy textbooks where it will become an example of an interstellar object, in photographs of thousands of observers saved on hard drives, in cloud storage, in archives, in the memory of people who looked through telescopes on cold nights and saw a faint green point, a traveler from another world. In media literacy lessons, where the leak story will be an example of how not to believe unverified information, the comet passed, left a trace, not physical, gravity too small to affect planetary orbits, but informational, cultural, educational. It changed us a little, taught us something, reminded us that the universe is vast, full of wonders, and the most amazing of them are real. There's no need to invent alien ships when reality itself is incredible. A rock of ice and dust, born at another star, flew through our system. This is already a miracle, enough to be amazed. June 2026, exactly 1 year since the discovery of Comet 3. I-Atlas. In academic circles, the date is marked modestly. Several scientific conferences, an online symposium dedicated to interstellar objects, discussions technical, dry, filled with graphs and tables. But beyond the scientific community, in broader culture, the comet left a different kind of mark. Quiet, imperceptible at first glance, but deep. In school curricula around the world, a new section appeared: critical thinking and media literacy. Education ministries in different countries, independently of each other, reached the same conclusion. The events of October 2025, the leak, panic, rapid refutation, showed the necessity of teaching children not only facts, but methods of verifying these facts. The 3 I-Atlas story became the perfect teaching example. A real event, documented, with clear chronology from the appearance of misinformation to its refutation. In one Moscow school, a 42-year-old computer science teacher conducts an open lesson for colleagues from other educational institutions. Topic: How to verify information from the internet. A class of 9th graders, 15 to 16 years old, who grew up with gadgets in their hands. The teacher shows on the screen that very post from October 25th. The first blurry image, English caption, anonymous source. She asks a question. What's the first thing you should do when you see this? Hands shoot up. One student answers, check the source. Another, reverse image search. A third, look at official NASA data. The teacher nods. Good. They remembered. The next 40 minutes of the lesson, practical work. Each student receives a set of images and claims found on the internet. Their task: determine what's true, what's manipulation, what's outright lies. Use all available tools. Check metadata. Search for original sources. Compare with official databases. By the end of the lesson, most manage. Some even find the fakes the teacher considered particularly clever. After the lesson, colleagues from other schools ask questions. How to motivate students. How to make fact-checking not a boring obligation but an engaging game. The teacher shares experience. Use current examples, stories the children themselves remember. 3I Atlas was in the news 6 months ago. Many saw posts on social media. Some argued with friends themselves, ship or Comet. Now, when truth is established, they can retrospectively analyze what went wrong, why the lie spread so quickly, how it could have been stopped earlier. This isn't abstract theory. This is a lesson from their own recent past. One of the teachers asks, "And if a new similar story appears in the future, will they be skeptical?" The teacher thinks, "Some, yes. Others will still believe. But even if we teach at least half the class to ask questions before reposting a sensation, that's already progress." In the United States, in Arizona, a group of enthusiasts creates a documentary film. Title: The Comet That Could Have Been a Ship, Anatomy of a Viral Story. Filming took 4 months. Interviews with astronomers who observed 3I Atlas. Conversations with bloggers who spread the leak. Discussions with psychologists explaining why people believe conspiracy theories. Footage of real observations. Scientific trajectory. Visualizations of the comet. Animation of how artifacts formed in fake photos. The film runs 48 minutes. Tone calm, not accusatory. The director, a 35-year-old documentarian specializing in scientific topics, says in an interview, "My goal isn't to ridicule people who believed. My goal is to show how easy it is to make a mistake if you don't know verification mechanisms, and how fascinating reality is if you look at it carefully." The film releases on a streaming platform in July. Gets 2 million views in the first week. Ratings high. Comments mostly positive. "Thank you for explaining without arrogance. Now I understand where I was wrong. Shame it's not a ship, but the comet is cool too." August 2026. Scientific journals continue to publish articles about 3I Atlas. In the year since discovery, 79 peer-reviewed papers have been published. Topics diverse. Chemical composition, rotational dynamics, coma evolution, trajectory modeling into the past, attempts to determine the star of origin. One particularly interesting article, published in Astrophysical Journal, is devoted to comparative analysis of all 3 known interstellar objects. Authors build statistical models, trying to estimate how typical Oumuamua, Comet Borisov, and 3I Atlas are for the general population of interstellar wanderers. Conclusions cautious. 3 objects, too small a sample for confident generalizations, but preliminary data indicates enormous diversity. Interstellar space is filled with objects of all different types, sizes, compositions. This is logical. Each planetary system is unique. Therefore, objects ejected from these systems are also unique. The article ends with an appeal to the astronomical community. More sensitive detection systems are needed to increase statistics to a significant level. In response to this appeal, the European Space Agency announces development of a new mission. The project gets the working name Interstellar Object Observer Concept, a space telescope in solar orbit specially designed for early detection of interstellar objects, wide field of view, high sensitivity, fast alert system. When a new interstellar object enters the solar system, the telescope detects it at maximum possible distance, gives the world astronomical community time to prepare an observation campaign, possibly gives enough time to send an interceptor probe. Budget estimated at 800 million euros. Launch planned for the early 30s. Long path from idea to realization. But that's how space projects work. Each mission, result of decades of planning. 3i Atlas inspired this planning. Without it, the project might have been postponed for years. Simultaneously, NASA is developing its own concept. Not a telescope, but a network of small satellites in different orbits, working as a unified system. Dozens of craft, each the size of a refrigerator, distributed throughout the inner solar system. They constantly scan the sky, exchange data, calculate trajectories. When the system detects an object with hyperbolic trajectory, an alert is automatically sent to all observatories worldwide. Cost lower than a single large telescope, but technical challenges different. Coordination of many craft, processing enormous data volumes, maintaining network operability. Engineers debate details. Astronomers wait impatiently for results because everyone understands the next interstellar object could appear tomorrow or in 10 years. Prediction is impossible. You can only be ready. September 2026. A new hashtag appears on social media. Real Wonders of Space. Initiative of science popularizers and amateur astronomers. The idea is simple. Publish photos and facts about real space objects and phenomena, emphasizing how amazing they are without any conspiracy fabrications. First posts get tens of thousands of likes. The Orion Nebula, a giant cloud of gas and dust where stars are born. Saturn's rings, consisting of billions of ice particles, each in its own orbit. A black hole in the center of galaxy Messier 87, with a mass of 6 billion suns, warping space around itself. Exoplanet HD 189733b, where rains of molten glass fall sideways at wind speeds of 7,000 kilometers per hour. A pulsar spinning 700 times per second, emitting radio pulses with the precision of atomic clocks. Each post accompanied by explanation, how it works, why it's amazing, where to learn more. No mysticism, only physics, only reality. And reality captivates. One of the posts is devoted to 3i Atlas itself, a collection of the best photos taken by amateur astronomers over 6 months of observations. Green coma, thin tail, elongated nucleus against a background of stars. Text explains. This is a comet from another star system. It formed around another sun billions of years ago, traveled through the cold void between stars for hundreds of thousands of years, randomly entered our system, spent several months in view, now gone back into the abyss. We'll never see it again. But for a short time, it was here. We looked at it, studied it, learned about it. A piece of another world touched ours. Isn't that a miracle? The post gets 500,000 likes, comments full of admiration. Sorry I missed it. Next time I'll definitely look through a telescope. Thank you for the reminder that reality is beautiful. October 2026. A year has passed since the leak. October 25th, exactly the anniversary. Several bloggers specializing in debunking conspiracy theories publish retrospective analyses. A year ago, the internet exploded with the story of a ship comet. What have we learned since? They retell events, show how the situation developed, where the key refutation moments were. Analyze why refutation didn't reach the same coverage as the lie. Offer recommendations, how to react faster, how to make refutations more viral, how to build trust in scientific sources. Discussion constructive. People share experiences. Someone admits, "A year ago I believed. Now I'm ashamed, but I learned." Others say, "I was skeptical right away, but didn't know how to explain to friends. Now I know." In the same October, posts appear in some conspiracy communities. Remember 3i Atlas? They still haven't explained everything. Unresolved questions are listed, most of which have actually long been explained in scientific articles. These people just haven't read them or didn't understand. Why was the shape so strange? The shape was ordinary for comets. Why did the speed change? Speed changed due to outgassing, a standard process. Why did governments refute so quickly? Because refuting lies is part of their job. But for convinced conspiracy theorists, no explanation is sufficient. Their belief isn't based on evidence, so evidence can't shake it. This is sad reality. Not everyone can be convinced. Some prefer to live in a world where there's a conspiracy around every corner, where nothing can be trusted except their own intuition. For them, the 3i Atlas leak will remain an example of how they hide the truth. Arguments are useless. You can only hope the next generation will be better prepared. November 2026, 1.5 years since discovery. Comet 3. I-Atlas at a distance of more than 1 billion kilometers from the Sun, between the orbits of Jupiter and Saturn. Speed 55 kilometers per second. Surface temperature minus 230 degrees Celsius. No activity. The object is completely inert, dark, invisible. Even Earth's largest telescopes can no longer see it. Trajectory known with high precision. Mathematical models predict position decades ahead. In 3 years, it will cross Neptune's orbit. In 8, enter the Kuiper Belt region. In 15, it will reach the inner part of the Oort cloud. In 20,000 years, it will leave the Sun's gravitational influence definitively and return to interstellar space. Further fate unknown. It will fly millions of years in cold emptiness until something changes its trajectory. A star, a planet, a molecular cloud, or nothing. It will fly forever. But in humanity's memory, the comet will remain. In astronomy textbooks of coming decades, it will be an example of an interstellar object. In media literacy courses, an example of viral misinformation and its refutation. In observatory archives, thousands of images available to future researchers. In personal memories of those who looked through telescopes on cold nights, a moment of connection with space, feeling of belonging to something greater. The comet changed the world a little, not dramatically, not revolutionarily, but meaningfully. It reminded us that the universe is vast and full of wonders, that reality is more amazing than fantasies. That truth requires effort to find, but this effort is worth it. That skepticism and curiosity aren't opposites, but allies. That you can be open to the new without being naive. That science isn't a cold list of facts, but a living process of discovery in which everyone can participate. December 2026 approaches. The year ends. A new one will begin. Life continues. Someone will remember. Comet 3i Atlas. Someone will forget. Someone never heard of it. But somewhere in school classrooms, teachers will continue to use this story as an example. Somewhere on amateur astronomer forums, they'll remember autumn 2025 when a green comet hung in the pre-dawn sky. Somewhere in scientific laboratories, researchers will continue analyzing data, publishing articles, building models. And somewhere in interstellar space, in the cold darkness between stars, thousands, millions of similar objects are moving. Fragments of distant worlds, wanderers of eternity. Some will someday visit our system, and if we're ready, if we're watching, if we preserve the ability to be amazed by reality without replacing it with fabrications, we'll meet them, study them, learn something new, and again understand how little we know and how much more remains to be learned. This is science, an endless journey to understanding, and each comet, each interstellar guest, a small step on this path.